Hey everybody, this is Justin Schell. I'm the director of the Shapiro Design Lab at the University of Michigan Library, and this is our video for the 2020 Visions event. I'm sorry that we can't be there in person to share some of our tactile project work with you. So first we started with some sort of off-the-shelf websites that could make tactile maps relatively simply. So this map is of the University of Michigan campus, and it was created by this site called TouchMapper. And that allows you to use OpenStreetMap data, and then it will create a 3D printable file directly from that data, which you can then 3D print yourself. The URL is touch-mapper.org, touch-mapper.org. But we wanted to go beyond sort of the overhead, Google Maps, OpenStreetMap kind of view and look at what it would be like to create an internal tactile map, a map that could be used for navigating interior buildings. And so we've had students in the lab who've been working on this for the last couple years now, looking at different layouts and plans that the library has produced and figuring out ways to make those more tactile. And so this is an example of one of their prototypes where they were taking an Illustrator file, which is a type of graphic file, and raising some of the lines that outline different rooms or different features to make it tactile. They also use some tactile text, and they've also looked at different kinds of ways to create Braille for these as well. And so this process has also involved using some different kinds of technology. We've worked with the Sign Shop at the University of Michigan to use what's called their 2.5D printer. And this can be used to create basically one raised level on top of a piece of acrylic or other kinds of material. And so it's a lot less material to use because you don't have to 3D print the base of it. You don't have to 3D print the foundational layers of it. You can just print the map right on top of an already existing piece of material. Another avenue we've pursued in the design lab in terms of tactile projects has been through something called the Tactile Universe. This is a project developed in the UK that uses satellite or telescope data to create tactile representations of various cosmic phenomena. What you see here is the M51 Whirlpool galaxy, and this was created using specific telescope data and then running through a process that used a 3D design program called Blender, which created then a 3D printable file. All of the Tactile Universe materials are open source and freely available for others to use. You can find them at tactileuniverse.org. The processes that it uses to create these three-dimensional objects isn't limited to just astronomical phenomena. Because it creates three-dimensional version of an image, our students have figured out a way to basically make any image tactile from it. This is an example from a Japanese scroll from, I believe, the 16th century, and making that tactile just from a photograph of it. We've also looked at other kinds of paintings and things like that. So there's really a lot of possibilities for creating tactile versions of different artworks, for instance, through this process. This process has also allowed us to create tactile diagrams as study aids for someone who may be blind or visually impaired, who can't traditionally see the diagrams in a physics textbook, for instance. So these are a couple that we've created using some Braille typefaces, as well as using the workflow developed out of the Tactile Universe, taking the diagram from the PDF of the textbook, and then laser cutting that into a tactile graphic so that the student could also engage with the example graphics that are in the textbook. These are just a few of the projects we've worked on at the University of Michigan Library's Shapiro Design Lab. Please email us if you'd be interested in exploring any of these as part of your own work or organization. We'd be happy to collaborate as safely as we can during the pandemic. Hopefully, Visions 2021 will be back in person, and we'll have more things to show, more results from our explorations in this area. and that we could see you in person. Thanks for your time, and please be in touch.